Hello everyone! In the previous video we did an AVL code analysis for the code in Java. In this video we're going to use the same code from the previous video to do a visual analysis on insertion. What I recommend is you guys go to my GitHub, download the code, you can look at it, try to trace it the insertion of these numbers at the top while I try to do my best to do a visual representation of insertion in that for the code in the previous video. Alright, so let's do it. So remember in the previous video that when we instantiate the code, when we instantiate the AVL tree, it calls out the root. So we're going to do AVL and our tree, and therefore root. But root is not instantiated until we insert a value or a key. So root. So here it is. So let's do it with the node, and I know the node doesn't have k, but we're just going to use k for key and h for height to keep things short, because I know this is going to take up a lot of space. L is going to be the left child and R is going to be the right child. So height is going to be 1 and key is going to be 10. Alright. And we just instantiated the node. So root is node. Node is now instantiated, and this is the node. Alright. And then we do go k equals 20. H is 1. And then recursively it upgrades the height for this node. So now this node is 2. And this is okay. And then we go for 30. Okay. Okay, 30. H is 2. L and then R. Okay. And then we so right here, this one is 1. H is 1. This one H upgrades to 2. And then this one here, H is 3, height is 3. This happens recursively. So now we're in the if statement and right case. And you know something from the right case that this will be X, this will be Y. Alright, go to the right case in the if statement in insertion. Oops, sorry about that. 2. Okay. and this one I believe right here, it is, this will be where T2 is, and then K30 H is 1 LR. And now if we had a value at T2, T2 would actually be here. We don't, so this is our new rotated this tree. Okay. Now we insert 50. Sorry, we insert 40. 40 right now. So okay, 40. We go in the insertion function here. Height is 1 L and R. Recursive call. The height is updated here. This is 3. Okay, now we get the balance factor here. So the balance factor here would be 1, take away 0. So this is -1. The balance factor, to get the balance here, we do call the get balance function. So we call get balance. It would be, this one would be 2. And this one, oh yeah, this one will be here. 1. So this one's, it's -1. Okay. Okay, so let's erase here so we have more space. Okay. We insert 50. K is 50. Height, and then L and R. Height is 1. We do a recursive call here. And then when we're doing the recursive call, we also call the get balance function, but we don't, I don't have time to go into that. So this goes 2. So if we do get balance, it would be 2, 1, so -1, and then here would be 1. Sorry, that would be, this one would be 1, 2. Sorry, this one will be 3, and this one will be 4. And then 3. So this one here, it is 3 take away 0. We call here, we get the balance factor. We're here in the recursive function. and the balance is this one. It is 3 and 0. So this one here is -3. So we go into our if statement here. We go into the if statement and we perform right rotation, right. Go to the if statement and go to the right. We did the right. So in the right rotation, you have this was X, this as Y. So you know 40 H2 L R K30 H is 3 L R K is 50 R. Oops, I forgot to add the height here. Height is 1 L R. Okay. And then in that, when you do the rotation function, right, we change the height, so we get that. We modify the height for X and Y. So this would be 2. Will remain 2. This will now becomes 1. And then go here. Now we get the balance factor. So here it is 0, and for this one we get the balance 2 take away 1, so 1 take away 2, -1. So this is balanced. And then we're going to insert $25. Okay. And then we'll put 25. We have no space here, so we'll just put 25 around here. Actually, just make things easy. Make this one short. Let's make this edge short. Okay. Now put 25 here. Okay, 1, recursively we go up, This is 2. This is 3. That one remains 4. So the problem is 1, 2, 3. 3 take away 1, negative 2. So this is in balance once we get the balance for 20. So go to your code, do the trace, and then we're going to have to perform RL rotation. In RL rotation, let me just double check. Let me get the code here. So in RL rotation, you're going to go to right rotate. So this will be Y. X right. And okay. Right. So yeah. And this is, let me just double check, just quickly double check here. Y is going to be, so when you do the insertion here, just quickly check my notes. So this is going to be Y, and this is going to be X. All right. We perform rotation. And this is would be T2. So what you're going to do here is going to be X. So we rotate, so we do we go K 30 H2 LR. All right, and then we go K 40 40H3 LR. Okay. And then here 40X Y, and then K50 H1 LR, and then during insertion T2 will move over here. So okay. So now here it is, RL. And then here we'll put 25. Okay, B1, and then L, and then R. Okay, and then we go here, and then we perform RR rotation. So now K3. Oh, so once we change it, these up, the H values or the height changes. So 2, 3, this is 1, this is 2. Okay, good. So K30 H is 3 LR. Okay. And then K20 H4 LR, and then we could put 10 here. All right, we'll do that. And then we merge them. So and then here 20 25. Yeah, put it here. Okay, equals 40. Okay. Alright, hopefully this is a visual representation on what's happening in the insertion code in the AVL code that we were talking about. Hopefully you guys understand this. Again, we're trying to do an analysis on insertion on the code mentioned in the previous video. Hopefully this is the visuals explain everything for you, or simplify it, or make it easier for you guys to understand the code. I know it's a long video, but thank you for watching, and I hope you guys have a great day.